Let's get started with our project. And the first thing you will want to do, you don't have to do it for this project, but you will want to do it for any other project that you have to rig for, is to make sure that you have assets that you can actually work with efficiently. And this means getting models delivered and organized in a way where you can start working with them. So we're going to use our Ace Hero, and you just need to open the scene file called O2 Ace Hero Start Model. And this is basically the Ace model that comes in the content with Modo. But I've already done some stuff to it to optimize it for rigging. And I'm going to walk you through over the changes that I did. But before I do that, I want to talk to you about some of the things that you might want to do when you get a model for rigging. So the first thing you want to do is to make sure that the meshes that you're getting are properly modeled for what the rig has to do to them. This means that meshes that are going to be deformed have topology that enables these deformations to happen. Because if you don't, then even if you create a proper rig for the character to use or the meshes to use, then they will not deform properly because the topology was never laid out to take into account these deformations. So what I mean by that is that you have some nice edge flows, especially surrounding areas where the deformations are going to be pretty complex. So that's usually the face of the character. So you can see here, for example, that we have some nice, good edge flows going around the area of the mouth. So that's good. This is what you want to see in a properly modeled face for the character. So we have that. Also around the nose. And this is a fairly low detail character, which is fine for our purposes. In some instances, you might get characters that have more detail in certain areas, but basically the edge flow is going to be mostly the same. So it's all looking good for the face of this character. He also has some nicely modeled eyebrows over here, as you can see. Ears, same thing. We can go down the neck. And then, actually, you know what? Let's hide the other meshes so we don't have to deal with that for now. And just focus on the body of the character. We can also examine the armpit area, so you can see that he's got some nice edge loops over there. This is something you will want to have. Nice edge loops over here. So that's good. Joints over here. The elbow area, you want to make sure you have enough divisions over here so that you can actually bend this part. Same thing for this part of the model. Yeah, there's good edge looping there. And so on. You can continue looking at how the loops are distributed. This model is very well modeled for our purposes, so we don't have to worry about that. But if you spot any areas where you think there's not enough detail or the edge loops are not flowing in the way they should, you need to correct that if it's your model, or if it's not, you have to send it back to modeling or to the artist that created it so he can correct those mistakes. You can also, and you should, check the mesh for integrity problems. So that means having double vertices or end-sided polygons or double faces, overlapping edges, holes in the mesh that sometimes are not visible, stuff like that. You want to make sure that your model is, well, you could say watertight closed, but in some cases that's not necessary. But you just want to check the integrity of the mesh, and Modo provides this mesh cleanup tool to get rid of any unwanted or unexpected problems. So it will try to merge vertices where applicable or fix problems by itself. In some cases, as I said, you might have to go and do that manually or ask the modeler to do it for you if there's any problems. But you should get rid of those before starting any work. So once you're done, and then you can start creating the workspace that you need for modeling. In some cases, some facilities have pipelines that take care of that. In other cases, you just have to make yours along the way, or if you're collaborating with other artists, make sure you set down some guidelines that everybody will use so that the project flows more smoothly. In this case, we've talked about naming conventions and organizing a workspace for rigging, so you might want to do that. But I'm going to show you what I did for my own purposes to this scene. And to do that, I'm gonna compare it with the shipping model that we have. So this is what ships with the model with Modo. Sorry, I'm gonna open the folder again so you can see where I got it. You just have to go to System, Content folder, and in the Samples folder we have Characters, Game, Ace Hero, and this is the original file that I used. So I'm gonna open it up so we can compare and I can show you what I did. So this is the original file, and as you see, the shield is over here, and what's going on is that the shield object, if we find it over here, has a morph influence applied to it, which is this one over here. And what they did is they just basically used a morph influence to position it on the arm of the character. So at 0 strength, it goes back to its original position. At 100% strength, it goes to the arm of the character. So all I did was I deleted the influence, because you're definitely not going to need that or want that or any other type of deformers that are included in the file. If you get a file with deformers or stuff like that from modeling, you should ask the modeler as to why those are there. And he should probably collapse those or just bake those into a new mesh if they were used for anything in the modeling session. So I just deleted those. And the other thing I did was, as I was examining the character and planning my rig, I decided that some of the accessories that he has, I might want to have them as separate objects. So in this case, these guys, all the accessories on the character are a single mesh item, and I thought that maybe at some point he will want to play around with his straps or with the goggles that he has. So it would be a lot better to have those as separate objects. So all I did was take that mesh item and do an unmerge mesh. That will basically take all the polygons that share welded vertices and separate those into a new mesh item. So for example, if I go into polygon mode and I double click on this object or this part of the object here, you will see that it selects only this part, and I can do the same for every shell that he has, and even for this strap, and it only selects that part because those are the polygons that share welded vertices. So I can separate those into a single item by doing an unmerge. So that's what I did. If we go back to the file that I created, and let's unhide everything, you will see that let's go back to items mode. I just unselect that. If I select this, it's a single item, and I can keep on selecting any of these, and they're all separate items. And the way this works is, as I was saying, I did an unmerge and I got separate items for everything, and then I went in and renamed each one of those individually, because we've talked about it. Naming conventions are very, very important. So I needed to know what I was working with. So I renamed everything and then just reshuffled things in the items list a little bit to have things grouped together a little bit better. And then I took everything here and I grouped it under a single group, which is the gear geometry group. And I also named that. And I did the same for the mouth interior, which, as you can see, it's these objects. So we have a mouth interior group with 3 different meshes, because I also wanted to, I unmerged the interior of the mouth so I could rig separately the upper teeth and gums from the lower teeth and gums and the tongue. So that's ready to be rigged. The rest was okay. We don't really have to care too much about all the other meshes. It also is fine if some of the mesh items are not closed, are not sealed. In this case, you can see that the tongue, the gums, and the eyes are cut. There's some holes in them. That's fine. We don't really have to care too much about those, because those are going to be in the interior of his head. And anyway, unless something horrible is supposed to happen to this character, we're not really supposed to see the backside of his eyes or his teeth and stuff like that. So this is fine. Same for the accessories. He's not going to remove them, so not having interior faces is okay. And that's it. That's pretty much it. This is something that might take you a while to properly organize and clean up, but it's going to pay off in the end. And especially in the case of the accessories, where I might want to animate those separately. Like, let's say, what if he's supposed to grab this shell and remove it so he can load it on a gun or something? Well, it needs to be a separate item, otherwise I'm not going to be able to do it. Well, actually, I could. you could do this using the formers, but if you want to use just plain transforms and controls and stuff like that, you will not be able to do it. So it all depends on how you want to rig this in the end. There's no real rules. Everything is just guidelines, and there's many techniques to accomplish the same end result. So it's up to your personal preference and the motions that the character has to perform to decide how you want to rig this, and based on that, how you want to organize your scene. But the point is that you should take some time before you start rigging to plan the rig out and organize your workspace to have the rest of the rigging process go smoothly. And again, name your stuff if it's not named. So that's pretty much what I wanted to cover when it comes to preparing the character for rigging. So now that all that is done, we can proceed with starting to lay out part of the rig for this character. So let's get over to that. Okay, let's start doing the guide for the character, and we're actually going to start with the arms. And the arms, I want to start with those because they're somewhat easy to do, and also they pose some interesting situations that will allow us to use some of the Modo tools in different ways. So let's start with the arms. And what I'm gonna do before starting to create the joint chains is I'm gonna prepare the scene a little bit so I can work a little bit more comfortable. One of the things that might happen when you're starting to rig something is that at some point, when your rig starts to become more complex and there's more stuff in the viewports, the meshes might start getting in the way. So especially when it comes to selections and stuff like that. And you don't want that to happen just to be able to work fast. You sometimes it's not nice that you're trying to select locators or stuff and you keep selecting the mesh and things like those. So what I often do is I make everything that is a mesh belonging to this rig unselectable. And the way I do that is I just select some of the, well, actually not some, I select the meshes on the character. As you can see here, I left those out on purpose. I'm going to show you why in a second. And I go to groups and I create a new group from that selection. So let's create a new group, and we're going to call it Ace Geo, and it's a standard group from the selected items because I already have them selected. So we click on OK, and as you can see, the group tells me there's 50 items in it, and it's all the meshes that I Add selected. And now with the group selected, I go to the Assemblies tab and I set member selectable to off. So that way I cannot select the meshes anymore. Okay, they won't get in my way. Now what about these guys? Well, I left them out in case you want to see how it's done once you have created a group, but you left some stuff out, or you start creating stuff in the scene and you want to add it to a group. Well, all you have to do is actually you select the objects that you want to include in the group, and you go to the group list again, you right click and you say add items. So these items get added to the group. You can see that the number changed. Now it's 61, and now everything is unselectable, which is great. So there we go. I use groups a lot for managing these kind of things in the scene, so I don't have to worry about messing up my hierarchy or trying to come up with something in the items list that would be kind of funky to get to work. Of course, groups also allow you to toggle visibility, which is great. We're also going to be using this a lot. So there. Okay, let's now get started with the rig. So what we're going to do is going to start using the skeleton tool to create some joints in our character. And we're going to take care of one arm and then just basically mirror that to the other side. Actually, we're going to try two different things. The first thing is there is a mirror setting on the skeleton tool. If I bring up the model palette with the skeleton options, you will see that there's this symmetry setting. So if I turn it on the x-axis, anything I create on this side is going to be mirrored to the other side. So for example, I could click here and you can see that another joint is created. And actually, let's do that. Let's switch to the front view. And let's start creating our skeleton. But before doing that, I'm going to use two other things. I'm going to try to use intersection, which will try to create the joints at the middle of a mesh, but basically shoots a ray at the point where I'm clicking in 2D space, and it tries to figure out for any mesh that is behind it, where is the inside, and it'll try to place the object I created inside of the mesh. So this helps keep the joints in the middle of the mesh. So we're going to see if that works. And the other thing I'm going to change is the alignment. So we've been talking about how to align your joints properly, and as I mentioned before, we determined that given that Modo's default rotation order is ZXY, we want to have the least used axis as the second axis in the rotation order. So in this case, it's going to be the X direction, which is going to be running down the bone. That's the movement we're going to perform less because it will run into a gimbal lock. So we want to use an X direction for the orientation of our bones. So I can set that up right from the beginning and not have to rely on the align tool as much. So let's see what all this gives us. So we have compensation turned on. This will allow me to move child bones without disturbing the parents, or the other way around. Actually, everything will move independently. Then we have intersection to place the joints inside of the mesh, and then we have symmetry to create both arms at the same time, and finally the direction alignment to keep a good alignment on our joints. So we're gonna click over here, then we're gonna click over here, and finally over here. At this point, I'm not really worrying too much about the precise locations of the joints, because as you can see, there's a little bit of an angle here. I'm gonna go ahead and tweak that once I move into perspective view. So let's actually do that. Let's go to perspective and see what we got. So that was not too bad, except this guy's outside. But we've got both joints, okay, both arms, sorry, created. And as long as I continue to use the skeleton tool, I can start to tweak these guys' positions. And as you can see, that also affects the other side, so that's nice. Let's move this guy over here. And this guy needs to be a little bit like that. This guy maybe a little bit over here. So that looks good. We're still gonna have to tweak this a little bit once we get into our orientations, and the reason is it's very easy to create by moving stuff around like this, to create a joint chain that is not planar, and you do not want non-planar joint chains. And the reason is, if you create a joint chain like that, once you start animating it, you will see things popping around, and that's because the rotations are not aligned on a plane. So I want to avoid that, but we're going to fix that later. Right now, all we want to do is get the joints more or less on their proper locations. And it seems good so far, so we can drop the tool. And let's see what we have. So we have this guy, and we can see X is running down the bone. Z is pointing backwards, Y is pointing upwards. And our mirror is over here. Let's see what kind of motions we're getting from these guys and the rotation values. So right now everything is zeroed, okay? And I'm just gonna bend this in local space and see if, yeah, we got a good rotation. It's slightly off. As you can see, the tip of the bone is not pointing towards this guy's center. Slightly off, but we're gonna fix that in a minute. Before fixing that, there's something else we need to address first, and that is the following. If I select this joint over here, you will see that the rotations are zeroed. But we've talked about this before, and we determined that transforms from any object are always in parent space, which means that any object's transforms are going to be the difference between its orientation or position against its parents. If an object has no parent, its parent is the world. So we can see that this guy definitely does not have the same orientation as its parent, which is this joint over here. This guy is rotated, otherwise he would be pointing straight down. So why is he zeroed in rotation? Well, the answer is, if we go and examine its channel list, you will notice that there's two rotation transforms in the channel list. The one in bold is your primary transform, and this is the secondary transform. And we can see that the primary is zeroed, but the secondary has values in it. So this is what's happening. When you create joint chains, Modo will store the actual transform values in the secondary and give you a primary that is zeroed, so that if you just want to start manipulating things directly and you say, okay, I'm going to rotate this guy this way and then that way and that way to do tests or whatever, and then you want to go back to your original pose, and you're like, wow, I don't know how to get back to the pose I originally had. All you have to do is zero any rotations you did, and it'll go back to that pose that was set when you posed things with the skeleton tool. Well, not pose them, but when you position the joints with the skeleton tool. So it gives you an easy way to go back to your original orientations, which is great. However, we don't want that on our guide rig, because we want to know at all times the exact rotation values of every joint, so that we can correct any problems that we might have in our rig and not have a headache later on. So we need to fix that. How do we fix it? Well, it's very easy. We just need to go into each joint, and in the channel list, what we want is not to have two transforms. We want to have a single one. So how do we do that? Well, there's actually a very nice tool, which is the merge transforms tool. The way it works is you select any number of transforms that you want to merge, and you right click. Of course, the transforms have to be at the same type. In this case, they are rotations. And you just say merge. And what that's going to do, it's going to take all the values on all the transforms you selected and merge them onto the last selected transform. It adds them up and it stores the result on the last selected one. So I selected the primary transform as my last transform, so everything goes there. So once I say merge, you will see that now the secondary is zeroed and the primary has the values that are the actual rotation values for that joint. So that's what I want to have. I want to have everything on the primary transform. And now I can right click on the secondary one since I don't need it anymore and just say delete. So I can delete my my secondary transform and just have the primary one. So I do that for every joint. I take the secondary, shift select to the primary, say merge. Now I have my values over here, and then I delete. And I do the same for the last joint. Merge, delete this one. And now it's fixed. If I go to my properties panel, you will see that now I can see the actual rotation values for that particular joint. Okay, and as you can see, there's some stuff here that we have to fix. So let's get started right away. And we're gonna take this joint, and to make sure we have a planar chain, I just want to have a rotation in Y, which is where the angle is for this joint, and the rest has to be zeroed. So let's 0 on X and let's 0 on Z, and there we go. We have a properly oriented joint. And the last one, we wanted to have the exact same orientation as its parent. So we're just gonna 0 everything. And now he has the same orientation as his parent. This one I don't need to worry about right now because he has no parent. So the rotation values are all gonna be kind of weird, which is okay. I don't need to worry about that now. And let's just check that all the joints are at the proper position. And here's one trick if you need to continue to fiddle things around. Don't use the move tool. Don't move your joints using the move tool, because that is going to create more problems later on. If you need to move joints, let's say that I need this joint to be a little bit more towards the hand. Well, what you need to do is you always move joints in parent space, not in local space. So you can do the same thing for this joint over here, for example. If I wanted it to be more, a little bit higher on the elbow area, if I move it in local space, what I'm going to do is he's going to move this way, and now his parent is not going to be aligned towards him. So I don't want that to happen. I want the parent to always be aligned towards the joint I'm moving, so I need to move it in parent space. And I do that by just deactivating local. So the move tool goes to parent space, and now I can move him and not worry about the alignment. So let's put this guy right over there. And if you don't want to disturb the child joint that you had, all you have to do is check child compensate, so the child stays there. But remember that the child is now the one that is getting misaligned, as you can see down there. So let's put this guy here, and let's now go to the child and move him down a little bit. Okay, that's it. Now we can actually don't turn off child compensate until you have dropped the tool, because Sometimes, especially with rotations, they'll pop back. And now we have properly oriented joint chain. Let's check that out again. See, we have no weird rotations. This guy is still good. If you think you have a joint that needs to go a little bit under, don't move it. What you need to do is go back to the parent of the chain and rotate that until you get it at the spot that you need him to be in. So that way our joint chain always remains planar. We don't have to worry about, actually, you know what? Rotations, I do need to make them in local space to make sure I'm only rotating one axis. That's probably a little bit too low, so let's bring him back up. Yeah, that's probably right. And I'm gonna move this guy back up a little bit. In this case, his parent and local rotations are, orientation is the same because we align him to his parent, so there's not many problems with this joint. And that's it. We are done creating our joints. The only problem is, because we've been manipulating this bone chain using the standard transforms, now the arm on the other side doesn't match. Whenever you use the standard transform tools, the transforms don't get mirrored. That only happens when you're using the skeleton tool. So I use the skeleton tool in mirror mode to show you that you could create joints on both sides, and if you're happy with what you have in the end, then you're done. But now this arm is basically useless to us, so I'm just going to select the entire thing and delete it, and we're going to mirror it. We're going to take the arm that we currently have and we're going to mirror it to the other side. But before I do that, we have to do something that we've talked about that is very important, which is rename our stuff properly. So let's take the first joint and I'm going to call it JNT, which is my prefix for joint. And then I'm going to give it a side. In this case, it's the right side because it's the side relative to the character, not to me. I want it to be always relative to the character. And then we're going to call it upper arm. Then we take the second one, and it's going to be JNT R lower arm. I know it should be forearm, but I tend to use upper and lower so things are more clear for me. And then JNT R wrist. There we go. So now we have a properly named joint chain. Now we can mirror it. So to do that, all I have to do is let's select our first joint, and we're going to use the mirror hierarchy tool, which is going to mirror the entire hierarchy, not just the selected item. And as you can see, there's 3 different axes to mirror on. And in our case, since we want the mirror to happen from this side of the character to that side, we can see that that is the X axis right there. So we're going to mirror on X. So I just select the first joint in the chain, mirror hierarchy X, and we get our mirror. You might say, well, what happened over there? It's all wrong. It's because this tool was mainly designed with geometry in mind, not joints. So one thing it does is it applies a negative scale on the axis you're mirroring. That's how it actually achieves the mirror. But we don't really need that. So we can just take off the negative scale and leave it as a positive scale. And then everything is nice and fine again. So let's do a little test here. Well, first I'm going to check that my mirror also, as you can see, its channels are clean. So that's great. Let's do a test. Let's see how things are looking in terms of the rotations. And one thing that is important is when you're mirroring joints from one side of the character to the other, you want to think about how the animator is going to use this, because in most animation systems, animators can copy and paste and mirror animation from one side of the character to another to save some time. So we want to make sure that the mirrors are properly oriented to allow this. So in this case, I want to, for example, when the character lifts his arm, I want this arm to also be lifted. And I want him, when he swings it back, this guy, he also has to swing back. And when he twists it, this guy should twist in the same direction, which in this case is the opposite one actually. But let's see what we're getting. So we're gonna select the first joint here, and then select the other one on the opposite side, and turn on local rotations. And let's see what we're getting. So when I rotate in Z, you can see that the rotations are not what I want. Right now they're following in the same direction. I want them to be following opposite directions. So, okay. Then in X is fine. X is rotating fine. This is what I want to see. And on Y, they're not good either. They are, right now they're flipped. I want the arms to go in the same direction visually, because they're actually opposite. But so what we need to do is we need to work a little bit on the orientations on this side. So let's select the entire joint chain, and we're going to use our trusty align tool. So let's see what we get. Right now it's set to X direction, Z axis, and let's just use the scene up axis. And if I do that, I get X going down, Z pointing forward, Y pointing up, okay? Which, if I compare again, will get us the following. Let's rotate again. So now the Z-axis is fine. As you can see, this is what I actually wanted. But Y is still flipped. And now X is flipped. So let's see what's going on. That means that for this chain to do what I want, I need X inverted, which is pointing up, and I need Y inverted, which is pointing down. But Z is working fine because on this side, Z is pointing backwards, and on this side, Z is pointing forward. So we need to fix the other axes. So to do that, the first thing I need is I need X to be on the negative axis. So instead of going down, it's going up. So let's try that. X, Z, negative axis. Oh, what happened? Well, since I flipped the X-axis, Z was flipped, not Y. So that's not going to work. What I need is XY. Now Z is pointing in the wrong direction. Now it's pointing this way instead of backwards. So I just need to set my up axis to, Z. So we have X, Y, and Z on the up axis with negative. And now everything is back to normal. Well, let's compare to see what we got. So we select both again, turn on rotations. We can see that Z, yeah, that's good. That's what we want. On Y, yes, now they're swinging in the same, to the same side of the character. And X, yep, that's what we wanted. So now this side of the character is properly oriented so that we can get animations to go from one side of the character to the other properly. Or at least we can grab both controls on both sides of the character and have those motions performed at the same time. So that's great. Let's just make sure that our rotation values on this side are okay. So let's go to this joint. We have a little bit of difference here because of how the align tool works, and it needs to be zeroed. And let's check this guy's angle. Let's copy that value and paste it there. It was a tiny bit of a difference. And then for these guys, we can see that there's some difference in values over there. But these rotation values, we're actually going to look a little bit more into them when we start parenting other parts of the rig onto the arms. Like we still need to create a torso, clavicles, and all that. So for now, our arms are done. I just need to rename this side. So let's take off the R and substitute it for an L and get rid of the numbered suffix. So L is for left side, no numbering. The rest of the name is going to be the same. And we're done. We've done the arms for our character guide rig. So now it's time to do the hands, and we're gonna do that in the next video. Let's move on.